Okay, let's move ahead. So in the last class, we had started with the map reduce, and we discussed that the for the computation part in Hadoop, what we have is the map reduce frame, which is part of the Hadoop framework. So in the last class, we did some examples, right? So this is another example where we are trying to count the population. So let us say you are assigned the task to count the population of India, and then it is divided into states. So for every state, one person is being assigned. So this is the task that you try to do. You assign one person for each state, and that person is responsible for doing this task of going to each house and counting the number of people around there. So, and then on the basis of that, we keep a count. So here you can say for the three states, similarly, we can have n states for, so you can say the complete job that we had, that job has been divided into the various tasks. So we are splitting that particular job, right? So how many splits, that will depend upon the size of the block, how many splits you are going to create. So the number of splits, the number of mappers are going to be equivalent to the number of splits of the data that we have. So depending upon the size of data that we have, we are going to create the splits of that particular data, right? So you can say, so like SFO, you can say this is the count of SO represents the count of state S1, then SJSO represents the count of houses and the number of members in each house in state 2 and state 3, and all these then they give the complete, you can say this is the task of the map function to count the, you can see these are the words or these are the frequencies, and similarly you can find out the stock prices, and like you just have to change the logic, the underlying function will remain the same. So right, and all these tasks after being done, that they will be sent to the reducer function. Then this reducer function is going to complete that task, and you know what is being done by the reducer. It has taken all the you can say the count of houses from the each of the states, and then it has combined the values of all these states, and here you can see every data that we have, that is in the form of key value pairs. So the key is the state and the value is the number of people in that particular state. So now you can say the mappers, they are basically managing the data, they are processing the data in terms of storage, and doing some task of sorting and shuffling, and doing some task of just counting, right? After the storage, what they do, see, basically the mappers, they process, let us say we have 1000 tuples, and these tuple or 1000 tuples are splitted converted into 5 splits. So each split is going to have around 20,000 divided into 5, 400, 400 or 4,000, 4,000 tuples. So each, this you can say the mapper, how it works is it reads line by line. It will read first line, see the what are the words in that particular line, and it will keep a count of the frequency of each of these words. Then it will read another line, then it will keep the frequency of count of all these words. So if you know that like in the various web searching programs or web searching projects, what do? So all we find out the keywords, and we see the frequency of these keywords when we have to apply the IDF model or the vector model. So in order to find out the what is the frequency of each word. So the similar kind of task is being done, but how in order to handle that particular data, we are doing it with the help of MapReduce. So finally, the reducer is doing this particular task. Now, what if we have to see, now here three splits have been uh, the you can say the whole data, the whole job is converted, the complete data is being converted into 3 splits. Now, what if, let us say, that you are asked that you have to complete this particular task at a faster pace? So in that case, what are you going to do? See, now in each state, each of the mapper is doing its task parallelly. All these 3 mappers are independent of each other, and the task is being done in parallel. So now if you have to speed up the task, what you will do, you will assign more mappers and to the same states. So now what we have done to the state 1, we have assigned 2 mappers. State 2, we have assigned 2 mappers. So that in order to speed up the task, say if you have to count the number of people around in this particular college, and one thing is I give the task to only one person, and another is I give the task to 2-3 persons. So it's very the 3 person will do the task faster as compared to the 1 person if we just have to count the persons, people who are there in the college today itself. So in order to speed up the task, although it was being done in parallel, but still it was taking much time. So in order to further increase the speed of the task to be processed, we are increasing the number of mappers. So the number of mappers, they are able to do this counting process in parallel, and they are able to speed up. Now the thing that is to be taken care of over here is that when we are now the reporting of these mappers is to the 2 reducers. So but we have to take care that the output of the mappers, that should not go to the you can say 2 different reducers. All the output from state 1, that should go to one reducer, and all the output from the another state should go to another, as shown over here. So the state 1, they are giving the input to headquarter 1, and state 3 also, it is giving to, its output to the headquarter 1. So the headquarter 1, it is having input from state 1 and state 3. Similarly, headquarter 2 is having input only from the state 2. So it becomes easy to maintain the count, and it becomes easy to do the processing. So it receives the headquarter 1. Now the headquarter 1 and 2, they need not interact because they are having the independent data. And finally, again, this task can be reduced. So it is already being done. The only task is to combine that particular data that has been received at the central location. So SFO 13, LA 9, SJOE 8. So all these are, you can say, compiled by the reducers. So you can say we have the task that is being done by the mapper is only counting the frequency of single words in every line. So in every line, it is just keeping a track of the number of words in that particular line. If they are similar, count is increased to 2, 3, 4, whatever is the count. And they are not interacting. The 2 records, they are not interacting with each other. And that particular task is being done by the reducers. So here you can say, so the first task of converting the main input data into the input splits, and then assigning the mappers, and then giving the output in the form of key value pairs. This complete task is being done in the map phase. Then we have a reduce phase where the complete data is being, so the output of the map phase is the input to the reduce phase. So there we have the reducers who are completing this task of you can say the processing the complete data and then giving the output, right? And in between we have the shuffle phase as well as the combiner phase. So what do the shuffle phase do? What do the shuffle phase do? In the shuffle phase, again, because the data is coming from the multiple mappers, so we may need to reshuffle, because there is a possibility that we have the different states data from being issued to the different states. So we let us say if here the data is being processed within the state. Now let us say in the state we have all the votes from the BJP, then JDU, then Congress, and then like that. So the shuffling process basically helps in this reshuffling task. Like the state data is being given to the reducers, which states are going to give the data to the headquarter 1 and or the reducer 1, and which states are going to give the data to 2. So that means which output is going to become the input for the reducers. So all this task is being done by the shuffle phase between the map phase and the reduce phase. So we were talking about the big data problem, that the example that we had discussed, finding out the maximum closing price for each symbol. So in this case, since we were talking about the data that we had received, that was 1 TB data, and we had a storage limit of 20 GB only. So what do? So we convert the complete data into the splits. So input split 1, 2, 3. So the complete data is broken down into multiple chunks, and each chunk is assigned to the member. So the number of, so if somebody asks you how many mappers are required for processing this particular data, so that means number of mappers is equal to the number of splits. If you have 5 splits, that means you require 5 mappers. right? So after so these mappers, what do? They read each record one by one. From each record, what they have to see is what is the question? The question is maximum closing price. So in this particular information, what we have, the name of the company and its opening and the closing price. So it will just look into that particular figure, record by record, and find out that if ABC, if its closing price is this, so and then if the next time if it comes across again ABC, because in the input split one, we may have 1,000 records, and the name of the company may be coming again and again, right? So for every value, let us say we talk about the ABC company, if its initial value was 74, and we have to find out the maximum closing price. So it will do what it will do when it comes across, let us say the first record was ABC, then the 10th record is again ABC. Now it will compare the values of the ABC's closing price and will retain only the that is the maximum of both. So you have to maintain the logic over here. So in the previous example, we were talking about maintaining the total count. So we were performing the addition operation over there, but here we are applying the max operation over here. Any questions?
And the presentation is not visible.
Not visible.
Yes, ma'am.
Let me share it again. Oh, give me a minute. It got disconnected by itself. Is it visible now?
Yes, ma'am. Now it's visible.
Okay. So in this example, we were talking about that MapReduce, this maximum closing price only. So I was explaining this, that the complete data, the complete stock data that has been converted into multiple chunks, and each chunk we can say it is called as the input split 1, 2, 3, like that. And the number of splits is equivalent to the number of mappers, or the number of mappers is equivalent to the number of splits. And if from each split, see, you may need to do any kind of task, whether you need to count the frequency of the words, or you may have to find out the maximum closing price. You may be given the employee data, and you have to find out the maximum salary the employee, right? So you may be given any kind of task. It may be some minimization, or it may be some maximization. So any kind of task may be there with you, which can be performed over the big size of the data, right? So we are trying to find out let us say we are selling certain about 10, 20 products, and we want to know the maximum sales of the product which has been sold at max within a month or within a year. It can be anything like that. So here we have seen that ABC, BDD, these are the name of the companies which are listed in the stock market, and these are the maximum closing prices from the split 1, then from the split 2, then from the split 3. Now from this, all these are the outputs of the mappers, but these are the inputs for the reducer. So from the reducer, so you can say between the mapper and the reducer, what we have, the shuffling phase. So in the shuffling phase, you can see that, see here, here I am showing you the combiner also. So combiner is basically optional phase. So combiner is also going to do the aggregation task only. So here you can see when we are discussing what is being done in the map phases, that we have received you can say received the maximum values of all the stocks which are there from the mapper, and then all these stocks are sorted, right? So they are sorted, after sorting they are being sent to the combiner. So after the sorting, you can say all these stocks are being sorted, and after sorting, we see since ABC was the occurring multiple times, all the values of the ABC these have been recorded over here in the sort function. We can see, and here we are applying the max, because we have to find out the max. See, if you had to find out the addition, you could add these values. If you have to find out the minimum, you can apply the minimum function. And if you want to find out the maximum, here at this stage, you can apply the max function. So what does the combiner do? You can see combiner is reducing this particular task by performing the aggregation. So applying the max function. So out of 60, 50, 111, the maximum value is 111. Similarly, the same function has been applied for each of the stocks by both the combiners, right? So you can say that for every mapper there is a corresponding combiner. And after that, what does the shuffling phase do? In the shuffling phase, all the inputs, all the outputs of the combiners, they go and they are reshuffled so that they go to their respective reducers. So all the data, so like ABC 111 was there from the node A, and ABC 100 was there with the node B. So now all these are combined. Now ABC is 111 and 100, so that we are further able to process the data. And then reducers, they are going to process this complete data. So the combiner is just helping us reduce the computation part. So if the combiner would not have been there, so in that case, the reducer had to find out the max of 60, 50, 111, 100, and 31. That is from both the node A as well as the node B. And this is for all the products, or you can say for all the companies which are listed. So combiner is helping out in reducing the task of the reducer, and then from the reducers, we get the final output. And here you can see at every stage, with the mapper also and with the reducer also, everything is in the form of key value pairs. So what is key? The key is the one that we are looking for. What is the name of the company? So from the query itself, you will understand that what is going to be the key. So the query is name the company which is having the maximum closing price. So the name of the companies are the keys, and the values are the values of the stock closing prices which are associated with them. So this is how the complete, you can say, the map reduce, the computation is being handled by the map reduce in Hadoop. So you can say this is the complete flow that we have seen with the help of the examples. So we have input data stored on the HDFS, and then it is converted into the appropriate input format, and after that it is splitted. So here you will see we are not going to split any data. I will be showing you one example. So we don't split, the splitting part is being handled by the Hadoop itself. So it goes to the record reader, which see what is being done from the input split. There is a record reader. What this is doing, it is reading all the records in the input file one by one, and then what they're doing is it is find out the mapper is basically find out the intermediate key value pairs. So here you can say these are the ABC 60, STT 82. All these are the intermediate key value pairs. Then we have seen the combiner. Here the combiner is working. It is find the aggregation of all these values, and then the partitioner. So the combiners and the partitioners, we can say they are doing the similar kind of tasks. So after this, they basically substitute the intermediate key value pairs, and then the sorting and shuffling is being done by the shuffling step that we have seen, the shuffling phase between the mapper and the reducer, and then the final output is received from the reducer. So output data is stored on the HDFS. We will see how we are able to get the data from the HDFS. So the mappers and the reducers are the user's code. Basically, we create these functions, right? Just to read and we have to obey the key value pairs. So we consume key value pairs. We produce key value pairs. The mappers, that means mappers input is key value pairs, and they produce also key value pairs. Reducers, they also consume key value pairs and produce the key value. So here you can say in case of reducers, they consume key and list of values, because here you can see this in this example, what we have ABC 111 and 100. So it is list of values, not just value. So it can be anything. In this list, we have one item or it may be multiple items. Then shuffling and sorting, they are basically the hidden between the mappers and the reducers. They group all similar keys from all mappers, sort and pass them to a certain reducer in the form of key and the list of values. And this list of values is the input or that is received by the reducers. So that was all basically the main architecture, main concept of the map and how does it work. So in the then we talk about the Hadoop streaming utility. Basically, it helps in executing or creating a map reduce script in any of the languages. That may be Java, that may be Python, or any of the. And it helps. Basically, Hadoop streaming is used for processing the task so that we can take the input from the standard input device and we can give the output to the standard output device. And for Hadoop streaming, like on the top, what we can have any of the programming languages because these are more user friendly. And to interact with the HDFS, here you so to interact with the Hadoop cluster, what we have in between the Unix streams, which help us in executing. See, Unix streams basically they help us in the execution of any of the scripts written in any of the languages. So basically first we are going to learn about the MapReduce program, that how do we execute this MapReduce program in the Cloudera framework. And then we are see or basically your Hadoop streaming program that you will be able to do it yourself, because that is very simple. Once we have done that, we are able to execute this particular example of MapReduce. So we will do one word count example in the MapReduce now. See, I'm going to share, you see, I have created this one file that is having all the steps so that you are able to do the complete task of executing the word count example in the Cloudera framework. So you can try out this particular task in the online. I have tried because Cloudera is installed on my machine. I have done the complete task on my machine only in the Cloudera framework. You can try out if it is possible to do in the other online tool facility that I have given the link. So just try out. Don't forget to do that. And because on this basis, what I am going to demonstrate today, on the basis of that, you are going to have one assignment which you will have to perform and submit along with the you can say the print screen of the work that you have done. Okay, so now I'm going to see, this is my what will happen. See, I'll show you. I have Cloudera installed on my machine. Basically, when you try to install the Cloudera, what you do is you get a zip file. This zip file itself, I'll show you what is the size. It is, I think, approximately 4 GB. Yeah, see, this is the size of the file. So for the to work in Cloudera, your system should have minimum of 8 GB RAM. Otherwise, you won't be able to do the task. So because see, the size of the file itself is 5.54 GB. The previous version was around 4 GB. So first you have
मैम
to download. Yes.
मैम क्लिक मैम ये मैम डिसकंटिन्यू हो गया है क्विक स्टार्ट वीएम मैम क्लाउडेरा की साइट पे है ही नहीं
ऐसा नहीं हो सकता है, अभी मैंने ये पिछले वाले सेमेस्टर में ही तो करवाया था बच्चों को, बच्चे ऐसा नहीं
मैम
हो सकता
डाउनलोड
है।
मैम साइट पे
सी
कहीं नहीं
मेरे
मिल रहा
पास व्हाट आई कैन डू इज मैं ड्राइव पे शेयर कर दूं आप लोगों को ये
यस मैम
है। तो मैं हाँ, ये मुझे पहले क्लिक नहीं हुआ, मैं ड्राइव पे शेयर कर दूंगी आप लोगों को।
जिप
ठीक है,
फाइल शेयर कर दो मैम वो कर लेंगे हम
हाँ मैं ये जिप फाइल आपको शेयर कर देती हूँ, इसकी जिप फाइल बना के, तो आप लोग फिर उसको डाउनलोड करके फिर इजी हो जाएगा आपके लिए। ठीक है,
ओके मैम
so that I will do. Okay, so what you have to do is, so first you go to this particular folder. After unzip, you will find this vmdk file. So this is basically the file that you have to double click and start. So when you will be clicking on this, first it will be asking you to see, I have already completed the process in the previous semester itself. So it will show you all the instructions that I have given you in the tutorial 1, right? So they are the steps to do the complete the installation process. So in the installation, you just have to specify the number of cores, the amount of memory, amount of space you want to allocate, because this is going to be a virtual machine that we are creating, right? So on the Windows platform, we are creating one virtual machine, right? And you can say that is going to provide us an environment in which we can do all the work. So this is a Cloudera virtual box environment. So once I click on this, I get this window, right? So this is what VirtualBox Manager. So I have see you will be getting this over here because it is already running. If I'll stop, I have done a few programs that I want to show you so that they will also stop. So here you will get this arrow. You just have to click on that start. If you face any kind of problem, you can just share your screen with me. You can discuss with me, share your screen over the meet and show me, we can resolve that particular problem on your system itself. Okay, so when we click on this, the system starts booting, and after that we get one, this kind of window, right? So basically I have opened the Eclipse. So basically you can see this is a complete desktop. You can say this is a complete system that we are working on. So you can say on the Windows platform, we have created one virtual machine, virtual environment, which behaves like one machine itself. And now here you see what are the various menus. Here we have the applications, where we have accessories, and here we have the system tools, where we have the file browser. So from the file browser, we can browse what is there in the complete directory of this. So it is, you can say here, it is the complete file system of your Cloudera framework, right? So here you see, so we have the Cloudera, we have desktop, and on the desktop, you can see, because for doing the map reduce program, what we have to do, as that when we have to do the Hadoop map reduce program helps in processing of the data. So if for the processing, HDFS is storing the data, and we have to create a reducer program, so which will read that particular data from the input, right? And then process it, do certain processing. And for doing this particular task, we have to write some code. And that code will be written either in Java or in Python, right? Any of the programming language. So here what we are going to do, we are going to do to execute the word count example using Java. So after going to the desktop, you have to double click on this Eclipse icon. And this Eclipse is already working over here. 1 minute. Yes, right. So here you see I have created these examples multiple times in the word counts, right? So what we are going to do, I hope you all are well versed with the Eclipse environment. Yes? Eclipse environment, you know, for working with Java? Yes, please tell me.
मैम जावा यूज नहीं की हुई.
तो उसमें कोई ज़्यादा कुछ नहीं करना है. See, in the Java, I'm going to show you that the word count example, you just have to understand the process, right? So instead of Java in the Eclipse, I guess we can work in the Python also, right? So here you just have to understand that how we are going to execute. So the complete Java program of the word count is already given on the web. We are going to copy that program over here, and we have to see the complete, you can say, the execution process, the complete pipeline that we have to understand, right? So there is a complete pipeline, how we are going to take the input, how we are going to write the code, how it will read that input, and how it is going to process, and then where we will see that particular output. So this complete pipeline we have to understand, and if you are able to understand that particular pipeline, in that case you will be able to do or use execute the program in any of the languages. That will become easy for you, right? So I want to want you to understand this complete pipeline. And for understanding this complete pipeline, I have see everything is mentioned over here in this particular file. So I'll be following this file only, and I will be showing you how to execute the map reduce program over here, right? So what do we do? I have you can say all the comments are there, all the screenshots are there, right? Now let us start with creating one example of the word count program. So what do we do? So I'm going to do it from the very beginning so that it becomes easy for you. So what do? We create one Java project. So I write word count. I'm writing is CL, means for class I've written. Okay. So after that, Here you see. See, here I have written this as it is, what is being done over here, right? And after that, you just have to click OK. Specify the name of the project what and click next. So, right, so over here, what we are going to do, we just don't have to finish it. We have to click on the next, right? And from the next, what is the important step that we miss out when we have to execute this program? That is importing the libraries. So we have to understand that in order to execute this particular program of word count into the Cloudera, we have to import the external jar files, which are the libraries for the execution of this particular program into the Cloudera, or you can say into the Hadoop. So here we are going to create a client program, right? For the client program, we are going to import certain libraries. So here you see libraries, add external jars, right? From the external jars, we go to the file system to the lib, not to the lib. 1 minute. A user, I guess. Yes, user, and from the user to the lib. Yes. So here we have Hadoop. So you have to see, because it's not easy to remember this particular path. I have written everything in this particular document, that what is the path. You have to go to the libraries, add external jar files, and then from here, see, you have to go to the file system, user, lib, Hadoop, right? And from the Hadoop, what you have to do, you click on this, and after clicking on the Hadoop, you have to import all these files, whatever files are there, starting from the annotations. Starting from the first jar file that you see in the Hadoop folder, you have to import all those files. Just click on OK. Now all these Hadoop jar files, they are there in your execution environment of your project, right? So if you write any of the commands, any of the code related to that, that will be executed. You won't be having any of the compilation errors, right? Then we add more jar files. So more jar files, because it is going to be the client program, what we have to do is we have to import all these files which are required for the execution of the client program, right? So again, I'm importing them. Just click on OK. Now all these files are part of my project. Then just click on finish, right? Now create, go to new, create class. Now I'm going to write the program, word count, right? So I write word count 1, let us say. Okay, just finish. Right? So I have already I have here, you see, I have provided you the path. See, all this task we have finished. Now, this particular task, we have created a class now, right? So here you see. So after that, we have to write. So we are able to we reach this particular step, and we are able to get the word count 1 class. Now from here, what you have to do, you have to go to this particular path, right? Hadoop, Apache, here you can see, right? So in this particular path, what you have is there is already a program of the word count that is available. So we just copy that particular program. I have already, since I have already written this particular program, I'll just copy it from here. See, this same program you will find over here. So the only thing you have to remember is, since I had given the name of the class file word count E in the previous example, so I have renamed it over as WE. So again, since in the new example that we are doing, so wherever we come across the class name as word count, we have to update that. Otherwise, we will be getting the error. So I'm just copying it first here. Now you'll see that here it is, the name of the class was class 1, but here it is, so I'll write 1, right? And I'll delete this, right? So after that, again at one place, see here, It is showing the error. So here again, I just have to replace it with 1. Or you simply directly, rather than writing, renaming it, you can directly use word count 1 only, word count only, so that you don't have to make any of the changes, right? Now, once we have written the program, here you see, so what is the program over here? So this is a mapper function. So what we have done is, so this is a mapper function, and this is, you can say, the reducer function. Here you see, right? So what does the mapper function do? It will read the input in writable, sorry. So here we are doing what we are doing. We have a text class which is going to help us to read the text. So what do we do with this map function? Here we have implemented string tokenizer. What the string tokenizer is going to do? So when we read one sentence which is written in the input file, it will break down that sentence on the basis of the spaces and then keep the count of each of the word, right? So this was the task being done by the map function. So this is the task of the mapper. And then here what we get, so this is the task of the reducer function. So here, because it is a word count example, instead of this sum, here see this sum is implemented over here. So you can make a change over here. You can make a change over here and you can find out the maximum value, minimum value, whatever is being asked in your question. And then see what we are doing over here, we are reading the values, whatever input is being received by the receiver, it is taking the sum of those values. And then it is adding it to the sum. So result dot set sum. So you can say because it is written in Java, so Java has its own API. In Python, it will have its own API. And after that, in the main function, this is the main function of Java, public static void main. So here it is setting, you see, job first function, that first class that we have called is we have created an instance of the job function. So what is configuration? Word count, simply we have given that particular name. Then after that, so what we have said jar by class. So we are going to create a jar file for this particular class, and then that will be read by the your Hadoop. We will be passing that to the Hadoop. We will see the further task. Then set mapper, then combiner, then reducer class, right? So here what we have done, we are specifying that over here. Which one is the tokenizer mapper? This is the combiner class. This is the reducer is the reducer class. Then output key class. Then output value class. So we have two classes. One is for the keys and another is for the values. And here you see file input format, that input job new path. So we are going to specify the name of the file, right, as command line arguments as for the input file, and as output file also we are going to specify what is the name of the file, right? And then it is going to show job.wait for the completion. If it is job is completed, is going to show 1. If it is not completed, it is going to 0 because it is still in the completion process, right? So from the rest of the task, now the further steps, since you can understand we have created a map reduce program for the word count in Java. Now how to execute this word count example, right, in the Hadoop environment, right? So this task we are going to do in the next class.